Thank you so much, and of course, many thanks to all of you for joining, guys. You can't imagine how happy I am to have you in this session. 2 weeks ago, I was around in the US. I was invited to give a talk at the Star East conference in Orlando, and they gave me a room for 500 people, and you know what? 5 people showed up. So you can't imagine how happy I am to have you here. So thanks so much for coming, guys. As mentioned, my name is Ingo Philipp. I'm on the product management team at Tricentis. Tricentis is a software company. We are located in Vienna, the beautiful capital of Austria. And maybe you already heard about our flagship product. It's called Tricentis Tosca. But don't panic. In this session, I won't talk about our company and I won't talk about our products. I want to exclusively focus on how to go from traditional testing to continuous testing to enable continuous delivery at the end of the day. So that's the master plan. I hope that works for you guys. Now, in order to safely dive into that topic, let me start with this. Guys, we are all surfing the same wave, the big tsunami of the big money now called digital transformation. And in 2014, Forrester already reminded us for the 10th year in a row that every single business out there must continuously create new sources of customer value at an ever-increasing operational agility. So how do we do that? Well, by exploiting digital technologies. And what is that? Well, that's software. It's any kind of technology that generates, stores, and processes data in terms of 2 states. So software definitely has the potential to fuel the fear of digital disruption. And so digital transformation is a software-led demonstration. And it's good for us because somebody needs to test that software. But the big question is, why the heck do we need to do all that so fast? Why do we need to ship our product so fast to our customers? Well, I'm at least convinced that all of our business is about one single thing. It's about a value exchange between your company and your customers. So how do we play that game? Well, the first thing we do is we try to identify the needs of our customers. We try to uncover their requirements. We try to understand their pain points, their problems. Now, once we did that, or we at least thought we've done that, we move on and build a solution to solve their problems. And we need to do that fast because the competition is just a single click away from us. Now, once we did that, we then move our solutions to the customer, and so we provide value to our customers by solving their problems. And the customers then provide value back to us by paying for what we have built, or by providing data, the new oil out there, right? So that's how we exchange values on a very high level of abstraction. And in order to accelerate that value exchange, we usually wrestle ourselves through the delivery pipeline multiple times a day at ever-increasing speeds, with the customers at both ends. So how did development now reacted on that? Well, guys, in the past, which still is the future for most companies out there, the entire software delivery process was carried out in separated phases. Phases which didn't know from each other until the previous one completed. And therefore, we call those phases the walls of confusion. And so it's absolutely no surprise that, for example, when critical defects were found in the later stages of that delivery process, this often caused the entire product to be rethinked, to be redesigned, to be re-implemented, and to be retested. And all this resulted in a long delivery cycle. Now, for that simple reason, then most of the companies then said goodbye to those traditional and waterfall-like delivery processes, and they said hello to more incremental or iterative approaches to software delivery, one of which is the rational unified process. Now, the overall goal of these processes was to parallelize all the activities that were going on in all those phases. But nevertheless, these processes also failed to solve the underlying issue, to compress the delivery pipeline. And for that reason, then also the large companies around Y2K then started to adopt agile development and delivery processes, such as Scrum, Kanban, LeSS, and the Scaled Agile framework. And this fundamentally changed the way how we develop, test, and ship our software products. Because we decided to move away from following rigid rules, and we've moved towards evolving in flexible frameworks. And I think this is perfectly described by all the principles in the Agile Manifesto. But these companies then quickly realized that product increments created by product development often cause severe problems on the operations side. And you know what? Then the blame game began. And all this then gave rise to the DevOps movement around 2007 and 2008. And that is where we are right now. So the bottom line, guys, is that we have moved away from revolutionary software delivery processes, and we've moved towards evolutionary software delivery processes. And what's the reason for that? Well, Darwin already knew it, right? It's not the strongest that survive, nor the most intelligent. It's the one most responsive to change. So it's no longer about mastering continuous improvement. It's about mastering continuous change. And this is especially of importance when it comes to software development. Because, you know, to overstate the case a bit, software is not written, it is rewritten. Now, guys, now I've put a lot of drama into that story, but now let's go back to reality and let's see how things are really working out these days. So when we talk to our partners, to analysts, and to customers, we usually see that picture on an average software development and testing project. We see that most of the testing still goes into manual testing, 80% or so. And this not only includes manual test case creation, the execution, and the maintenance. This also includes manual test data, localization, and preparation during manual test execution. And just a small fraction goes into test automation, where most of the test automation is carried out on the level of UIs, the user interfaces. Less is done on the level of APIs. And aspects such as load testing, security testing, well, these guys are almost not present these days. And now from this simple perspective, we can derive easily two major challenges. The first one, it's obvious, it's manual testing. It's just the top technical challenge in any sort of app development, period. Number two, it's test automation itself. And this still surprises me because it's out there for ages already. And test automation is still regarded as a developer's discipline because it still asks for comprehensive coding and scripting skills. And from this simple perspective, it becomes perfectly obvious that you as a tester, as a plain manual tester, you can't survive and so succeed in any fast-paced development environment when you so heavily rely on manual testing and when you're not able to create and to maintain a test automation solution. And therefore, we say that the future of testing for companies in that situation needs to look like that. And here I just want to highlight 5 points. Number one, we need to achieve automation rates far beyond 80%, 90%, or even higher to keep the pace with agile development. Now, how do we do that? Well, we need to have a key enabler at hand to achieve that. And that is what we call orchestrated service virtualization. The third point is API testing. So we are convinced that the future of test automation must focus on APIs, to leverage APIs, to scale your test automation to almost any arbitrary level. Number four, we want to do away with discontinuous load testing. We want to move towards continuous load testing. So we don't just want to shift it to the left, we also want to shift it to the right. And we want to do away with the fact that load testing is just done right at the end of a certain iteration. We want to do it continuously. And the last point I want to highlight here is connected to the first one. So due to the dramatic increase of test automation, also the effort in manual testing needs to decrease dramatically. But in doing so, we also say it needs to transform into exploratory testing. Now that's, guys, in a nutshell, how we at Tricentis see the future of testing. And now let's dig into at least some of those points to also tell you why. Let's first start with API testing. So why the heck should we even care about that? Well, in order to figure that out, let's have a look on how the degree of completion of UIs and APIs usually evolves over time. Now, when it comes to the user interfaces, you will get a picture like this. You will start with an initial idea on how your UI should look like. And this is maybe based on a mock-up. And then you start your UI implementation. But already right after the first feedback gets into the game, you most probably will rethink your UI proposal. And you most probably will redo your UI implementation. And this usually happens over and over and over and over again in the course of a single cycle. And you must be lucky, really, really lucky, guys, to just complete your UI implementation in the course of a certain iteration. And here the question is, do you guys think you can keep the pace with agile development when you have a single-minded focus on UI test automation? I don't think so. In contrast to that, the APIs evolve like that. They're much earlier available in the testing phase. So they allow you to start testing much earlier. And in contrast, or in addition to that, API test automation, in contrast to UI test automation, it's much easier to create and it's much easier to maintain. Why? Because the APIs are just way more stable than the UIs. And API test automation, without a shadow of doubt, is just damn faster than UI test automation. Now, API testing then lays the basis for what we call orchestrated service virtualization. So what does that even mean? Well, guys, when we arrive at our customers, we see system landscapes that look like this. They look like disease gene networks. Huge networks of interrelated and interconnected external as well as internal systems and system components. But where are you? You are right here, right in the middle, and you need to take care about your system or your system component. But in doing so, you also need to wrestle yourself through all your surrounding systems in order to account for proper enterprise end-to-end testing. But what happens in reality? Well, in reality, most of the systems are either broken, they're unavailable, they are under maintenance, under development, they're simply not accessible. And so the only thing you can say at this point in time is, welcome to the tester cell, right? You're not able to repeat your test execution without interruption anymore. And so you need to have the ability to virtualize or to simulate the communication between your real system and your surrounding systems. And we also generalize that idea in our projects. We don't just simulate the communication between the real system and our surrounding systems, but also the communication between all surrounding systems, all simulated services. And what it gives you at the end of the day are stable test environments. And this then makes test automation repeatable and stable. Now, guys, with all that, I just want to say one thing, that API testing and service virtualization, those two guys just represent the fundamental pillars of our approach to test automation. And automation in general, as we all know, and I don't want to stretch too much on that, is just the dictate of today, because it doesn't make testing easy, it makes testing even possible. But the big question now is, well, is automation the only thing we need? Is it the silver bullet that solves all of our problems? Well, guys, let's see. And let's see by visiting this beautiful city here, London. And now, guys, imagine you are a tourist, and you just have 1 or 2 days time to see London. And you don't just want to be a tourist, you want to be a prepared tourist. So that means you want to see the right places at the right time. Okay? Now, for the sake of simplicity, imagine you just want to visit those 2 sites. Let's call them Site A and Site B. And that might be the Westminster Abbey or the Buckingham Palace, for example. And now the question is, well, in how many different ways can we visit those 2 sites? Well, there are 5 ways out there. I can decide not to visit any of the sites. That's the trivial case, right? Number 1. Number 2, I can decide just to go to A. Number 3, I can decide to go just to B. Or number 4, from A to B, and number 5, from B to A. And maybe that makes a difference, right? I learned something at A, I can reuse that at B, or the other way around. So 5 ways to visit those 2 sites. So now, guys, now imagine that London represents your application, your software product, the software product you are about to test. And every site in London represents a certain function or a certain feature you want to test. And as we all know, London is a pretty big city, right? And so do your software products. So there's a lot to see, there's a lot to execute, and there's a lot to test. And now apply that logic, the same logic we have applied to those 2 sites, to those 50 sites. And ask yourself the question, well, in how many different ways can you test those functions? Well, guys, it turns out to be pretty long way. It's about 100 billion ways to do that. And now you might say, well, that's crazy. That's ridiculous. It's baseless, right? I don't need to do that. I mean, why should I have the need to execute every possible function in every possible sequence relative to all the other functions out there? And you're absolutely right. You don't need to do that. But you won't just have 50 functions in your application. You will have thousands, hundreds of thousands, even millions of those beasts you need to test. And so the only thing I want to say by that simple picture here is that we will never be able to test everything as exhaustively as possible, because we will not have the time, the resources, and the budget to do that. But we can always test as much as possible. And so the only question we have to answer at the end of the day is how much risk left over are we willing to accept when we release our software products. So the bottom line here is it's not just about testing harder in terms of being faster, in terms of more and more and more and more automation. It's about testing smarter. So now the question is, what are these smart things? Well, in order to explain that, let me start with an observation. The observation is on how fast the number of test cases usually grows over time. Here, for example, in units of certain iterations, sprints. So in some sprints, you will add more test cases to your regression test, for example. In some sprints, you will add less test cases to your regression test set, and so on and so forth. But all I want to say is that the number of test cases will grow. And no matter how fast or how slow that quantity will grow, at some point in time, guys, and that is what I can guarantee to you, you will hit a limit. We call this the critical limit. And this limit just tells you that you won't have the time, the resources, and the budget anymore to execute all of your test cases or to even maintain those artifacts. And then you need to make a decision, right? You need to make a decision, well, which test cases do I need to execute in which sequence to mitigate maximum business risk, early as possible? Or even more radically, you could ask yourself the question, well, which test cases am I allowed to keep alive to not get drowned into maintenance efforts? And without a risk-based approach, you simply can't make this decision. You simply can't make it. Because in really rough terms, a risk-based approach allows you to categorize your test case portfolio, let's say in low, medium, and high-risk areas, so that you can carry out light testing or even no testing in those low-risk areas, moderate testing in those medium-risk areas, and thought-of testing in those high-risk areas. And when you apply such a risk-based approach, not just on the level of requirements, epics, themes, user stories, stakeholder needs, features, call them however you want to call them, you will see that you can do a lot with a little. That means mitigating maximum risk with just a small set of test cases. And that's the reason why we apply a risk-based approach not just on the level of requirements, but also on the level of test cases in all of our agile projects. But in doing so, we also need to avoid the fact that the number of test cases we create over time explodes. So we need to avoid what is known out there as the combinatorial explosion of our regression test set. So we want to avoid that we hit this critical limit early as possible. We want to hit it late as possible. And how do we do that? Well, by applying a structured and methodical approach to test case definition, which we call test case design. Now, guys, and we do all that because of the fact there are so many and so much risk in our software products. And when I'm talking about risks, I'm talking about anything that has some potential of losing something of value. Now, these risks are then realized, they are actualized as problems, as issues when we release the software product. And these issues then come in many, many different flavors to us, such as functional issues, performance issues, reliability, accessibility issues, scalability issues, usability issues, safety and stability issues, and so on and so forth. And one essential part of our daily testing business is to identify all sorts of issues out there. And because of the fact that there's so much risk in our system, our software product basically looks like this. Also after we have released the software and properly tested it. And this is basically the result of software development. And guys, I've been a product owner for a couple of years at various software companies. And this is how I would describe the discipline of software development, because it's a lot like wrestling in the mud with a pig. You know, after a few hours, you realize the pig likes it. And you know what? The pig is the software here. Now, when this is software development, the big question is, what the heck is then software testing? Well, then software testing is like washing that pig. And as we all know, that can be messy, because it has no rules, it has no clear beginning, no clear middle, no clear end. And you know what, guys? Sometimes it's kind of like a pain in the ass. Because when you're done with testing, you're not even sure if the pig is really clean or why you were washing the pig in the first place. So now let's see how we wash the pig, guys, how we test software. And in order to understand that, let's first imagine that this rectangle here represents your software product, okay? It represents the entire functional and non-functional spectrum of your software product. So that's all there is, and that's all you could possibly know about your software product. Let's imagine that. Now then, the green rectangle represents all what you currently know about your software product. And that rectangle is apparently smaller than the previous one, because I'm at least convinced that you will never be able to always know everything. Now, the red rectangle then represents all what you repeatedly check in your software products by, for example, test automation. So that's all your knowledge that you have codified, okay? And again, it's apparently smaller than the previous one, because you will never be able to check everything at any point in time in your application. And the question here is, would it even make sense to strive for it? Would it even make sense to strive to codify all your knowledge? Well, I wouldn't say no. Because if you would codify all your knowledge, how would you create new knowledge? And you have to create new knowledge because your software product constantly grows. And so you constantly need to expand your knowledge about your software product to also reveal all those problems that are far outside your checking regime. And this is exactly what testing means to us at Tricentis. Testing is all about closing this knowledge gap. It's all about closing the gap between what we know and what we don't know. Now, how do we do that? Well, if you take software testing as one entity and rip it apart, you get two parts, the two testing cultures. The first one is confirmatory testing, and the other one is exploratory testing. So these are the two disciplines we use in order to reveal those problems. So let's briefly compare those two guys with each other so that we have a shared understanding. Confirmatory testing, well, that's a very mechanical approach to software testing, especially when it comes to test automation. Because automation is just doing what automation does. It just processes predefined data through your application in a predesigned set of actions. And that's it. On the other side of the fence, exploratory testing is more like an intelligent approach to testing. So here is all about learning the product, designing tests, executing them, and interpreting the test results all at the same time. So you do all of this simultaneously. And in doing so, your next test is always influenced by the results of the last test you did. And for that reason, we call that approach to testing exploratory testing. Now, this says one thing, that confirmatory testing, as the name already suggests, is all about monitoring known risks. So here you just confirm what you already know. You just confirm your existing beliefs. Whereas the purpose of exploratory testing is to analyze potential risks. And here you should focus on things you don't know. You should focus on illusions you are holding true without any empirical evidence. Now, this then implies that any exploratory test has a high information value associated with it, because we learn something new about the application. That's not the case with confirmatory tests. And now you might say, well, that's easy. So let's prioritize all of our tests according to their information values. Well, that's one way you could do it, but it's not the only one. Guys, don't miss the risk coverage. And without a shadow of doubt, you won't be able to achieve comprehensible risk coverage just by doing exploratory testing, because it's simply hard to scale. So you can only achieve comprehensible risk coverage in conjunction with confirmatory testing. So the bottom line is that confirmatory tests, these are change detectors. Now, why is that? Well, imagine you add some new functionality on top of your big fat software product. And then you want to immediately know if that has some bad impact on your already existing functionality, right? So what do you do in that case? You run your automated regression, fully embedded on your CI and CD pipeline. Now, on the other side of the fence, exploratory tests are more like problem detectors. And here, James Bach nailed it once by saying, here is all about exploring the unknown, the invisible, to avoid the unthinkable happening to the anomalous. Now, guys, confirmatory testing is all about checking. It's all about evaluating a product by applying algorithmic decision rules to specific observations of a product. Now, what the heck does it even mean? Well, in simple terms, this means here just try to find an answer to the question, does this assertion pass or fail? And that's it. And the answer to this question always provides a binary result. And so, the process of answering that question is machine decidable. It's algorithmic. It can be encapsulated by computational rules. It can be automated, and it should be automated, guys, because we don't want human testers doing something a machine can do, right? We want them doing exploratory testing. And exploratory testing is not so much a body of mechanical checks. It's all about evaluating a product by learning it through exploration and experimentation to uncover those unknown problems. And this usually requires a huge set of human activities, such as modeling, questioning, studying, inferences, and many, many more. So to sum it up, guys, checking is all about verification. It's all about verifying through specific instructions. And here you solely pay attention to the deviations from the expected results of your test cases. So it's all about creating test cases. It's all about following predetermined procedures. And why do that? Well, to examine specific conditions in your requirements. And by reducing testing to checking, by reducing testing to confirmatory testing, testing becomes a factory process, where you take requirements, you put requirements in, and you get test cases out. Now, on the other side of the fence, exploratory tests, they are more like investigations. It's all about investigating through powerful experiments. And here you don't pay attention, only pay attention to the deviations from the expected results of your test cases. Here you pay attention to what is known out there as test oracles, things that help you to find problems. So it's not about creating test cases, it's about creating test ideas and following clues. And here you don't examine specific conditions in your requirements, you examine risks. And by doing that, testing then becomes an adaptive investigation rather than a factory process. So here the risks and your findings, that is what guides your search. That is what guides your testing. Now guys, with all that, I don't want to say that we value exploration over checking. I don't want to say that we value exploratory testing over confirmatory testing. That would be way, way too simple. The only thing I want to convey to you is that we regard something as properly tested when it has been checked by efficient confirmatory test automation, of course based on a solid test case design, and when it has been explored by the richness of intellect of human beings, by you guys. So it's not just about the one or just about the other. It's about both at the same time. So this is our agile equation of motion. And guys, this is the reason why we pay so much attention to a structured approach to exploratory testing in all of our projects. So guys, now we have seen quite a lot. We scratched the surface of API testing. We touched service virtualization. We talked about risk-based testing. We briefly mentioned test case design. We talked about the relation between exploratory testing and confirmatory testing. But the question now is, well, do these disciplines even make an impact? Because if those disciplines don't make an impact, then the absence doesn't make a difference. So let's see if these guys really make a difference. And let me show you that based on a project we started off already 2 years ago in the banking sector. And this project was all about securities trading. That means trading of financial instruments, such as funds, bonds, the derivatives, shares, and even metals. Now, the initial condition of the project was that all of testing was in manual testing. So there was not a single automated test case in their regression test set. And in that project, about 11 manual testers were around. And those 11 manual testers, they had to execute and to maintain about 5,000 end-to-end regression test cases. And these regression test cases were scattered across more than 10 different technologies and platforms. Now, it took those 11 manual testers about 10 weeks to just execute that regression test set, and had no idea about their risk coverage. Now, the interesting story about this example is that the goal of this company was to be able to ship a potentially shippable product within a single week, but they had no idea how to do that. And so what they did, they gave us this charter, and I'm not joking, this was our project charter. They just told us, well, Ingo, there's a way to do it better, find it. And of course, we accepted the challenge. So now let me guide you through step by step what we did in order to let that dream become reality. So the first thing we did is we just captured, structured, and prioritized all the requirements on the level of themes, epics, and user stories that were part of the game. And then we took those 5,000 existing test cases and mapped it onto these risk-weighted requirement structures. So by this, we just made the risk coverage visible. Okay, it turned out to be 40% or so. And that's not bad, because all those test cases were created completely intuitively. So they didn't really have a structured approach to test case definition at hand. That is what we did in the first 2 days. In the next 2 weeks, we then applied test case design. That means our structured approach to test case definition. And by doing that, we achieved 2 improvements. The first one is we reduced the number of test cases by a factor of 4, while we were increasing the risk coverage close to 90%. 80% was the goal. And there was no black magic involved in that. So what we have seen in those 2 weeks is we have seen that there were so many high priority requirements that were completely under-tested or no tested at all. And we've seen so many low priority requirements completely over-tested. And in addition to that, the redundancy level in that regression test set was incredibly high, about 70%. And that's not an exception from the rule. We see it day in and we see it day out in almost every project. Now by this, then the execution time went down to 5 weeks. And then we obviously had a problem, right? Because we reduced the number of test cases by a factor of 4, execution time just went down by a factor of 2. And this then says that all the test cases we have redesigned here, or newly designed, took twice as long to execute as before. So we've made the situation even worse, right? And we analyzed that for 2 days, for 3 days, and we didn't figure that out. And after 2 or 3 days, those guys came to me and said, Ingo, to be honest, we never managed to execute all those 5,000 test cases in 10 weeks. We didn't even know that we have so many test cases. So the actual regression test time was about 15 to 17 weeks. And then we were happy again, right? So because those numbers were then aligned. We didn't make the situation worse. We're still in manual test execution, guys. Still in manual test execution. So the next test we did, the next step we did, was we applied a synthetic approach to test data management. So what does it mean? It means we created all the business objects that were part of the game completely synthetically, artificially. For example, customers in the banking application, their cash accounts, their custody accounts, even the transactions and the financial instruments, to have full flexibility during test automation. And by this, we were able to reduce the execution time again down to 2.5 weeks. Now, this implies that these guys spend more than 50% of their valuable testing time during manual test execution just to search for the right test data for the test cases. And this is ridiculous. So huge saving here. Again, we are still in manual test execution. So then we've established a solid basis for test automation. And then we went to test automation. So we achieved an automation rate close to 90%, where 2/3 of all the tests in absolute terms were based on APIs, web services in that case. And just by doing that, then the execution time went down to 48 hours on a single machine, automated regression. So what we then did is also distributed those tests across multiple machines in the test labs. So we took 6 machines, execution time went down to 8 hours. And after that, we also extracted a smoke test portfolio in order to check the basic functionality as often as possible. So what did we do that? Well, we selected the most important 7% of the test cases. What do I mean by that? Those test cases that contribute most to the overall business risk. And we were able to do that because we didn't just apply a risk-based approach on requirements level, but also on test case level. So we searched for those guys, we took them, and we embedded that in our smoke test portfolio. And this smoke test portfolio then mitigated 50% of the business risk in about 30 minutes to 1 hour. And we took that smoke test portfolio and embedded that into the automated CI and CD pipeline. So this end-to-end smoke test portfolio was then executed on demand multiple times a day, whenever some crazy dev checked something in. And we also executed it in periodic time intervals, in nightly builds, for example. But you know what, guys? The best part we got out of this project was that we were able to reduce the number of critical defects in production by more than 70%. And we measured that for more than 1 year and compared it to the results of the last year. I know that's a fuzzy metric, but still it's a huge result. And it's really hard to explain what actually contributed to test success. But my gut feeling says that testers really learned again how to test and not just how to check. So the main contribution here was a structured approach to session-based exploratory testing. And all these guys, this just took us 3 months with about 2 manual testers. And with that, I don't just want to say how cool we are here at Tricentis. I just want to say it's not a big deal to achieve all that. So guys, please also start remodeling your traditional approaches for great agility. I think that's the reason why you are here. Why? Because the future doesn't just get happen, it gets happen, so make it happen. Thank you so much for patience, guys.